Good day and welcome back to my channel. Today we will be looking at part 2 of the fundamental counting principle. Just to recap on the previous video, let's look at an example. In how many ways can the letters of the word marks be arranged? Repetition of letters is not allowed. Now, since there are 5 letters in the word marks, they can simply be arranged in 5 times 4 times 3 times 2 times 1 ways. Because in the first position, you can put a total of 5 of the letters, any 5 of the letters. In the second position, we can only put 4. In the third position, we can put 3, and so on. So the answer to this question is simply 5 times 4 times 3 times 2 times 1. This can also be written in factorial notation as 5 factorial, which is simply just equals to 120. Now, in this video, we will start by looking at repetition. So, what about the word Bobby? How many ways can the word Bobby be arranged? Now, we have to note that the letter B is repeated thrice. Dealing with repetition, in the word Bobby, B appears thrice. To account for this, we divide by the number of ways that B can be arranged. So, simply what we would do is, we would say there's 5 letters in the word Bobby, so they can be arranged 5 factorial ways. And then we divide by the number of ways the repeated letter or letters can be arranged. And in this case, the letter B is repeated 3 times. So it will be 5 factorial divided by 3 factorial, because there are 3 B's in the word. Let's look at an example. The example reads, given the word Mississippi, and don't worry, I also struggle to spell the word, determine the number of different ways that the letters can be arranged. Now, there are 11 letters in the word Mississippi, and we notice that there are 4 S's, 4 I's, and 2 P's. So, to find out the number of ways that the letters can be arranged, factoring the fact that we have some letters that are duplicated, it'll simply be 11 factorial. So, it's 11 factorial because there are 11 letters in the word Mississippi, and now we have to divide by the repeated letters. So, there are 4 S's, and 4 S's can be arranged in 4 factorial ways. There's 4 I's, and 4 I's can also be arranged in 4 factorial ways. And lastly, there are 2 P's, and 2 P's can be arranged in 2 factorial ways. So that's how we'd approach a question like this. And this simplifies to 34,650. So even though there's so many letters being repeated, there's still 34,650 ways, or different ways, that the word Mississippi can be arranged. Let's look at another example. Given the word probability, how many ways can the letters be arranged? Now, there are 11 letters in the word probability, and there are 2 B's and 2 I's. So to find out the number of ways that the letters can be arranged, it's simply 11 factorial, because there are 11 letters in the word, divided by 2 factorial, because there are 2 B's, and the number of ways that the 2 B's can be arranged is 2 factorial ways, and there are also 2 I's, so the number of ways the I's can be arranged is 2 factorial. And this simplifies to 9,979,200. So with just this 11 letter word, it can be arranged in almost 10 million different ways. Let's look at the next part of this question. If the word has to start with the letter B, how many ways can the letters be arranged? Now for this example, since the first letter is fixed, we can simply treat the word as a 10-letter word, since we only have 10 letters to play with. So, The answer to this question would simply be 10 factorial, because we're treating it as a 10-letter word since the first letter is fixed. And now this is important. Since the first letter is fixed as a B, from the remaining letters there's only one letter that's repeated, which is an I. So we're going to divide by 2 factorial. There's only one B left in this space, so it's not counted as a repeated letter. Hence, our answer is simply 10 factorial divided by 2 factorial. And that is simply 1,814,400. Let's look at the next part of the question. What is the probability that the word starts with a B if a random arrangement is chosen? Now, this third part of the question involves both the first and the second part of the question. In order to get the probability of the word starting with the letter B, we need the number of different ways that the word can be arranged if it is to start with a B, and divide that by the total number of ways that the letters in the word can be arranged. So simply, it's the answer in part 2 divided by the answer in part 1. And that is 1,814,400 divided by 9,979,200. And that simplifies to 0.18 or 18.18%. Let us quickly recall an example that we did in the previous video. A bank safe requires a 4-digit code. How many codes can be made if repetition of digits is not allowed? And the answer to this is simply 10 times 9 times 8 times 7, because in the first position there's a total number of 10 digits that can be used. In the second position there's a total number of 9 digits that can be used because repetition is not allowed. And so forth with the third and the fourth positions. Now, this can also be written in factorial notation as 10 factorial divided by 6 factorial, because 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And 6 factorial is simply 6 times 5 times 4 times 3 times 2 times 1. And the numbers 6, 5, 4, 3, 2 and 1 will cancel in both the numerator and the denominator, and we'll be simply left with 10 times 9 times 8 times 7. Now, examples of this kind can be performed more simply using the next slide. When dealing with selections, there are a limited number of places to be filled by a group. Like in the previous example, if we have R spaces to be filled by n different choices, the number of possible arrangements that can be made are simply n factorial divided by n minus R factorial. Let's apply this in an example. There are 12 contestants in a race. How many ways can first, second and third place be arranged? Now, since there's a limited number of spaces to be filled by a group of people, this is a selection problem, and we use n factorial divided by n minus R factorial. Now, if we recall, n was the total number of choices and R was the number of spaces available. In this case, the number of choices are 12 because there's 12 contestants, and the number of spaces is 3. So substituting into the formula, it's simply 12 factorial divided by 12 minus 3 factorial. That simplifies to 12 factorial divided by 9 factorial, which is equals to 1,320. That means that even though there's only 12 contestants in the race, The number of ways that first, second and third place can be arranged is 1320. If you enjoyed this video, please give it a thumbs up and subscribe to my channel.